buckle up and get ready for a mind-blowing cosmic adventure. Right now, take a peek outside and tell me, what's the first thing that catches your eye? The sky, the clouds, the sun, or maybe some twinkling stars? It's all super familiar, right? But here's the thrilling part: venture out of our home planet and suddenly, that same old sky is about to become unrecognizable. Yep, the sun will still be shining bright, but get ready for a whole new celestial show. It's gonna look like nowhere you've ever seen before. Time to put your detective hat on and uncover some cosmic secrets. Let's start by proving a cool principle right in your own backyard wall. Or should I say, living room. Take a closer look at how light behaves. You know that floor lamp nearby? Grab an object and move it closer under the beam, then watch as it brightens up. Now, take that same object and slowly back away from the lamp. What happens? That's right, the light gets dimmer. This is called the inverse square law in action. And it tells us that the farther something is from a light source, the less intense the light shines on it. Get ready to apply this principle to some out-of-this-world scenarios next. Buckle up, we're about to take a cosmic road trip. Let's see how our light intensity rule plays out on a real-world scale. Our star, the sun, is like that trusty floor lamp back home. The closer you get to it, the brighter and hotter things get. But if you move away from the sun, just like we did with that object under the lamp, things start to cool down and dim out, literally. Let's make Mercury our first stop in this interplanetary journey. This tiny planet is actually really close to the sun, about 36 million miles away on average. That's super close considering the vastness of space, but what does that mean for light intensity? Here we go. Let's talk about the smallest and speediest planet in our solar system, Mercury. This tiny Titan is not only the smallest, but also the closest to our star, the sun. Its orbit takes it as close as 46 million kilometers, or about 29 million miles away from the sun's blazing light. But don't get too comfortable. This distance changes all the time because Mercury's path around the sun isn't a perfect circle. Its orbit is more like an ellipse. It zips through space at breakneck speeds, taking just under 88 Earth days to complete one full rotation around our star. So, if you were living on Mercury and loved celebrating holidays, get ready for back-to-back New Year's Eve and Christmas parties. Let's dive into what makes Mercury's surface so unique. It's actually pretty similar to our moon's. Imagine vast plains stretching across the horizon, dotted with craters formed by asteroids and comets crashing down over billions of years. But that's not all. This scorching hot planet is also incredibly tiny, which means it doesn't have a thick atmosphere like Earth does. Basically, there's nothing to protect Mercury from extreme temperature fluctuations. We're talking record-breaking highs of up to 427 degrees Celsius or 801 degrees Fahrenheit, and chilling lows of minus 173 degrees Celsius or minus 279 degrees Fahrenheit. And if you were standing on Mercury, gazing up at the sky, you'd see a sun that's around 2.5 times bigger than what we experience here on Earth. Talk about a solar showstopper. But we're not heading to Venus just yet. Did you know that this scorching hot planet's landscape is actually dominated by over 1,600 major volcanic features? Yes, folks, that's tens of times more volcanoes than our own Earth. The surface of Venus is an incredible 90% solidified basalt lava flows, a testament to its fiery past. Imagine walking on a vast sea of cooled molten rock, the result of intense volcanic activity that shaped this alien world over millions of years. Get ready for a sizzling fact. Venus has an atmosphere so thick and heavy, with a whopping 96% carbon dioxide content, it creates a runaway greenhouse effect. This extreme environment traps heat, causing surface temperatures to soar up to a mind-blowing 462 degrees Celsius or 863 Fahrenheit. That's hotter than a blast furnace, despite being about the same distance from the sun as Mercury. The result, an otherworldly landscape with an orange sky that looks more like a vibrant Fanta drink than anything we've seen in our own planet. But hold on to your hat, Venus does things differently. Due to its super slow rotation, a day on Venus starts with the sun rising in the west and setting in the east. Talk about turning our usual morning routines upside down. The thick cloud cover also creates an eternal twilight, making it seem like daybreak never actually arrives. As for our home planet, Earth is chillin' at a comfortable average distance of 150 million kilometers or 93 million miles from the sun. And guess what? Our atmosphere makes that stunning blue sky we know and love possible, something Venus's thick blanket of clouds sadly blocks out, making those epic sunrise views highly unlikely. The moon plays a key role in making solar eclipses possible. A total eclipse is like nature's ultimate light show, but let's not get too comfortable exploring our home turf. We've got an amazing intergalactic adventure awaiting us, and Earth's secrets are already well within your grasp. So buckle up, because we're off to the red planet Mars. This incredible world orbits the Sun from a distance of about 230 million kilometers, or 143 million miles away, which is just far enough for it to rock that bold red hue we all know and love. Keep in mind that Mars' distance from the Sun can fluctuate slightly, but don't worry, we're talking tiny variations here when you consider the universe's massive scale. To put these enormous numbers into perspective for us mere mortals, imagine them as gigantic leaps compared to Earth. Now let's dive into what makes Mars so unique. Its atmosphere is incredibly thin and mostly made up of carbon dioxide. Talk about a gas giant difference from our breathable air. And if you're thinking of packing your sunglasses, forget it. This unforgiving world is also icy cold. There you have it. No wonder Mars remains a chilly world given its distant spot from the Sun. But the harsh climate paired with those epic dust storms, that's the perfect recipe for an otherworldly landscape. Unlike our hunches about other planets, we actually have loads of real-life evidence to paint a vivid picture of what Mars looks like. Its breathtaking sunsets and sunrises give us a clue. On this alien world, the Sun appears as only 2/3 its usual size back on Earth. So, is Mars just a myth with tales of being blue? Think again. It's indeed the red planet we've heard so much about, and those stories weren't just poetic phrases. Mars' iconic red hue is as real as it gets, a rusty shade we've all come to associate with this mysterious world. You might remember the gripping scenes from The Martian, where the reddish landscape seemed almost surreal. Well, let's break it to you. That cinematic depiction was incredibly close to reality. As sunsets and dawns unfold on Mars, they do cast a unique glow, subtly shifting the surrounding colors, just as they do back home on Earth, but with an otherworldly twist. But Mars' atmosphere doesn't just stop at that rusty hue. It filters sunlight in its own distinct way. Now, let's take a thrilling detour to the Jupiter system, but not to the gas giant itself. We're headed for a fascinating moon instead. Europa, with its icy surface hiding layers of silicate rocks beneath, is an enigma waiting to be unraveled. What sets this celestial body apart is its striking lack of craters, making it one of the smoothest objects in our solar system. Talk about a cosmic anomaly. So, let's see how the Sun would appear from Europa's icy shores and uncover what secrets this moon might hold. Imagine standing on a spaceship hovering above Europa. This icy Jovian moon is about 483 million miles away from the Sun, making it tough to spot. When you look up, the Sun would appear as small as 1/5 of our full moon's size. But that's not all. Jupiter's massive gravitational pull often steps in and temporarily blocks the Sun's rays, casting a cosmic shadow over Europa. Now, let's blast off towards another stunning planet, Saturn. Get ready to face intense gusts of wind. But with your imagination as our guide, we'll conquer these strong breezes and take in the breathtaking sights from above this ringed beauty. Buckle up and get ready for a chill adventure. Saturn is about 800 million miles from the Sun. That's almost 10 times farther away than Earth. This extreme distance makes it one of the coldest places in our solar system, with temperatures ranging from freezing cold at -113 degrees Celsius to an icy blast at -173 degrees Celsius, or roughly -172 to -280 degrees Fahrenheit. And you know what that means? Sunlight here is a staggering 90 times weaker than what we're used to on Earth. It's like gazing into a faint spotlight. But don't let the dim light fool you. Saturn's breathtaking display of ammonia ice clouds and its magnificent rings, stretching across hundreds of thousands of miles, would still leave us in awe. Next stop, get ready for an interplanetary thrill ride. But before we blast off, let's talk about our chill companion, Uranus, the ice giant that takes its sweet time. It makes one full orbit around the Sun in a whopping 84 years, which means it's not exactly speeding through space. Maybe it knows something we don't. When you're as massive as Uranus, there's no need to hurry. But don't let Uranus' laid-back vibe fool you, Dow. Things can get wild up there. Did you know that its winds are absolutely mental, reaching speeds of a scorching 900 kilometers per hour? That's way too fast for us to hang out on the surface, so let's head over to one of its moons instead. Say hello to Ariel, which is an astonishing 3 billion kilometers away from our star. That's over 1.8 billion miles. From here, the sun would appear as a massive dot in the sky, rather than a blazing fireball. And the best part, it's much, much dimmer, shining hundreds of times weaker than what we're used to on Earth. Scientists are super curious about Ariel and have discovered that it's made up of roughly equal parts water ice and dense rocks. Talk about an out-of-this-world composition. Brr. Ariel's average temperature. A chilly 213 degrees Celsius, 350, 1 degrees Fahrenheit. That's colder than the coldest winter night on Earth. And with no atmosphere to speak of, the sun would appear as a pale white dot rather than its usual fiery hue. Now, let's embark on our final cosmic adventure and journey to the last planet in our solar system, Neptune, an impressive 4.5 billion kilometers, 2.8 billion miles away from the sun. But I'm not done yet. I've got my eyes set on Triton, Neptune's fascinating moon. Stay tuned as we dive into its captivating world next. Let's get ready to geek out over Triton, Neptune's icy gem. This moon is packed with mind-blowing features. It's got a solid stone core, an icy mantle beneath, and a crust made almost entirely of water ice. But that's not all. Triton also boasts cryovolcanoes that blast nitrogen instead of lava into space. Now, about its atmosphere, it's mostly nitrogen, but don't worry, it's super thin. As for the sun, if you were on Triton's surface, it'd appear as a tiny dot in the sky, 30 times smaller than we see it from Earth. And to make matters even more dramatic, sunlight would be an astonishing 900 times dimmer. Can you imagine gazing up at such a distant and faint sun? The mystery surrounding Triton is just as captivating as the moon itself. Scientists have proposed numerous missions to explore Neptune's icy gem, but funding has always been the missing piece. For now, we'll continue to rely on our imagination and incredible visuals to learn more about this distant world. Who knows? Maybe future discoveries will reveal even more secrets of Triton. Thanks for tuning in. If you enjoyed this video, hit that thumbs up button. Don't forget to subscribe to keep exploring the universe with us, and click on the notification bell